Right, we have this question in front of us, and what we need to do is to solve for x. And we have several quadratic inequalities here, like the first, the second, and now D is a rational function, rational inequality, and also another rational inequality in C. But it is interesting that we want to focus on these inequalities and how to solve these for the unknown values of x. We proceed as follows. Right, so part A. Right, so part A will actually be solved with ease because it is exactly x squared minus twice x is less or equal to 15, like this. So how do you solve for x here? You need to first transpose the 15 so that you have x squared minus twice x minus 15 is less or equal to 0. We multiply x squared with 15 and we obtain minus 15x squared. We look for two expressions whose product is minus 15x squared, but its sum is minus 2, which is minus 5x plus 3x minus 15 is less or equal to 0. Factorizing with x into x minus 5 plus 3 into x minus 5, like this. We factorize like this. Okay, next, given that in part A, we actually have x minus 5 into x plus 3, like this, we proceed to focus on what we call the critical values, like this. And the critical values are x equals 5, x equals minus 3, like this. And so now we can put them here, like so. So we have the linear factors, x minus 5 with x plus 3 as well. And then what next do we have here? And then we have with us, so you can draw a horizontal line here, like so. And then we put here minus 3. We put here 5. Right, and then we draw a vertical here. We draw another vertical there. And then at the bottom of this, we put x minus 5 into x plus 3. To the left of minus 3, take an arbitrary number like minus 5, which minus 5 will give us negative, minus 5 plus 3 will give us negative. The product of these will give us a positive. Between a negative number and a positive, you can always choose 0. 0 minus 5 is a negative, 0 plus 3 is a positive, and therefore the product is negative. Okay, bigger than 5, 10, suppose, can be chosen. 10 minus 5 is a positive. 10 plus 3 is positive, and the result is positive. So if we're interested in where this is negative, it is actually obviously in between. Hence, the conclusion in this case is that we have that minus 3 is less than x, less than 5, but we have the equalities here like this, like so. Right, so, and this becomes the answer. Next one, you'll have part B to solve. Let's focus on part B. What is part B? So in part B, we have 4x squared plus 1 is greater or equal to 5x, which means 4x squared minus 5x plus 1 is greater or equal to 0. So what are the factors of this here? 4x squared by 1 is 4x squared. We look for two expressions whose product is 4x squared, but whose sum is minus 5. And those are minus 4x minus x plus 1. Pull out 4x. And then you have x minus 1. Here you have x minus 1. You have x minus 1, 4x minus 1. Like so. And then we focus on what we call the critical values. What are the critical values? They are exactly x equals 1, x equals 1/4. Part B, which means that we're going to choose, take the linear factors x minus 1, 4x minus 1, and then you have x minus 1 into 4x minus 1. All right, like so. And therefore, which means that you have 1/4, 1. So, right to the left of 1/4 will be any number that you can choose. Suppose 0. 0 minus 1 is negative. 4 by 0 is 0 minus 1 is negative, and this one is exactly a positive. Between 1/4 and the number 1, you can pick any arbitrary number here. This is like 0.25. Okay, so if it is 0.25, you can pick any number that is close to that, to 1. For example, that is a 0.9, for example. So 0.9 minus 1 is clearly negative. And here you will surely get a positive if you put 0.9 by 4 minus 1. Okay. So that as a consequence, bigger than 1, you can pick any number 10. For example, 10 minus 1 is positive. And you pick a 10. 4 by 10 is 40 minus 1 is 39 positive. So that here you have a positive here, and here you have a negative, like so. And then what is the answer? Recall that we were dealing with this inequality that is greater or equal to 0. And therefore, where do we have greater or equal to 0? So the positive is when x is less or equal to 1/4, or when x is bigger or equal to 1. And that is the answer. That is the answer. And we proceed. We proceed. Okay. The next question is part C. Right? What is part C? We are given x over x minus 3 is less or equal to 0. At this point, we're interested in what we call the critical values. X is 0. X is 3. Okay. So with these critical values, we can put them like so. You can put the expressions, these expressions here. And then here you put the rational expression x. Here you put a 0 and then you put a 3. Like so. Smaller than 0. A negative number like -1. It's going to be negative. We substitute here. -1 minus 3 is a negative, and this is positive. Between 0 and 3, a 1, making this a positive, making this a negative, and this is a negative. Bigger than 3 makes this positive, makes this positive, and makes this positive. Okay. The question we asked ourselves, what is the answer here? If this is less or equal to 0, less or equal to 0. So we're looking for less or equal to 0, and we can see that less or equal to 0 is between here. And hence, the part C means that our solution is going to lie between 0 and 3. But most importantly, it's going to lie between 0 and 3 so that we have that 0 is less than x, less than 3. But most importantly, because of this inclusion here, we're going to include 0. But we most certainly agree that 3 itself is not included. Why? Because in mathematics, we do not allow division by 0. So this becomes the final answer. This becomes the final answer to the problem. And we are done there. And then we proceed to look at D. Proceed to look at D. Right, so what is part D? In part D, we have exactly x squared plus twice x plus 3 divided by 6 x squared plus 13x minus 5 is less or equal to 0. Right, so upon further examination, you can see that x squared plus 2x plus 3 does not have linear factors, so that we have twice x plus 3. In the denominator, we continue to analyze this with so much caution, and we can see that if you multiply 6x squared by minus 5, we get minus 30x squared, so that we look for two expressions whose product is minus 30x squared, but whose sum is exactly plus 13, and those are 15x minus 2x minus 5 is less or equal to 0. X squared plus twice x plus 3. And then you actually, okay, there's an x here. Like so. There's most certainly an x here. That's a 15x minus 2x. Let's write clearly. A 15x minus 2x. Right, so now we factor out here. If factor out, we factorize, if factor out 3x. Factor out 3x, we're left with twice x plus 5. Factor out here. Twice x plus 5, which is less or equal to 0. Now, twice x plus 5 is a common factor, meaning we focus on part D. The numerator remains exactly x squared plus twice x plus 3 divided by, we pull out the twice x plus 5 as a common factor in the denominator of this rational inequality. At this point, we have the critical values. What are the critical values? They're exactly x equals minus 5 over 2, x equals 1/3, like this. And then if you look at this, we need to solve this and use these particular critical values and put everything on what we call a sign table. So we are going to look at what we call the sign table. And then we have x squared plus twice x plus 3. Twice x plus 5. Three x minus 1. You continue. And then we have x squared plus twice x plus 3 twice x plus 5. So right, so we have minus 5 over 2 and we have 1 over 3. And we focus on this here. This is the real number line of the values of x. So if you take an arbitrary number smaller than minus 5 over 2, for argument's sake, maybe minus 10, and you put it here, you realize that you're going to get a positive here. If you put it here, you'll get a minus 20. If you take a minus 10, you put it here, minus 20 plus 5, which is a negative. And here, minus 30 minus 1 is a negative, and this one is positive. Positive, this one. Between a negative and a positive number is 0. If you put 0 here, it's going to be exactly a positive. If you put it here, it's a positive. You put it here, it's a negative. And this becomes a negative. Bigger than 1/3 can be any arbitrary number. Say 10. Plug it in there, you have a positive. Plug it in here, you have a positive. Plug it in there, you have a positive, so that this is a positive. So now what is then the solution to this? The solution to this is, if you look very carefully, we're looking for parts where this is less than or equal to 0. Less than or equal to 0 is between minus 5 over 2 and 1/3. So the answer becomes, as a conclusion, minus 5 over 2, like so, and 1/3. Okay, if it's minus 5 over 2 and 1/3, you need to look at the fact that both minus 5 over 2 and 1/3 okay in the denominator, and therefore as much as this is less or equal to 0, but we cannot allow the denominator to actually become 0. So this is the final answer to the problem, and we are done. And thanks everybody for watching and for your time, and goodbye to you.